Let's talk about the operand forwarding. Okay, I told you there are 3 points to remember in the stalling. That is, the updated value is always we get from the right back. Okay, no same stage is occurred in the same clock cycle, and we cannot take the wrong value at the beginning. The second point is same for the operand forwarding, but the first and third point is change for the operand forwarding. What is the first point of operand forwarding? We get all the automatic value after execution. Okay, and second point is we get the value of load and store after memory. Okay, it means what? We can use the updated value like R1, R2 plus R3. Okay, we can use the updated value of R1 after the execution because it is the automatic operations. So there is less clock cycle than the stalling in the operand forwarding. Let's solve one question by using the operand forwarding, that is R1, R2 plus R3, R4, R1 plus R5, R7, R1 plus R6. First solve this question using stalling. Then we compare by stalling and the operand forwarding. Simply there is no any instruction before that, so simply we have to do IF, ID, execution, memory, and the right back. Now for second, this R1 is dependent with this R1, and we know in the stalling we get a value of R1 in the right back. So before that we cannot take the wrong value. So IF stalling, here we get the value of R1, so ID, then we can perform the operation, the execution, memory, and the right back. And third point is we cannot start the next instruction phase or anything below the stalling. It means we cannot start instruction phase from here because there is stalling. Below the stalling there is stalling, so we can put stalling. Then from here we can phase the data, the instruction phase. See, is R6 is dependent? No. Is R1 is dependent? Yes, R1 is dependent from this. And from where we get this? It means we get the value of R1 this. It means there is no, if I can take ID here, there is no any hazard. So I can take IF, ID, EX, MEM, WB, and total clock cycle. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9. Okay, let's solve by operand forwarding. The first is same, simply IF, ID, EX, ME, WB. Okay, and third point is in the operand forwarding we can take wrong value in the beginning and updated later. See how can we solve this. Okay, IF, this R1 is stored updated here. Okay, I told you in the operand forwarding we get all the automatic value after execution. It means after the executions, after third clock cycle, I will get my updated value of R1. And I also tell that first we can take the wrong value. Okay, if I take ID here, it means I am taking the wrong value of R1. Okay, it means 2 plus 3 it is 5, it is 4 plus 5. The first I have taken wrong value of R1, that is 4. Okay, but the condition is before doing the executions I have to update it the wrong value with the right value. Here I am taking the wrong value, so if I am doing execution here, it means after third clock cycle I get the operative value. It means I can use this operative value ex here by this arrow. Okay, it means what? Execution is finished. I will get operative value of R1 and I use this operative R1 in before this executions. Then MEM then WB. Okay, then simply IF is no dependency. R1 is dependent with this. It means IF ID. We can take this value from this EX ME WB. 1 2 3 4 5 6 7 clock cycle 7. It means operand forwarding helps to reduce the total number of clock cycle. In the upcoming videos, we are going to solve many more questions by using stalling and the operand forwarding to clear your concepts.